Before we begin our topic of discussing composting, let's do a review of some of the definitions of soil characteristics that we have talked about already, like soil texture. Soil texture, as you probably know by now, is the relative proportion of sand, silt, and clay, the three different size particles of the minerals in the soil. So it is not the organic matter, it's not the water or the air or the microbes, it's just the inert, abiotic rest of it, the mineral content. The silt, as we have discussed, is the medium-sized particle, sand is the largest sized particle, and clay by far the smallest. It takes about 65 million clay particles to fill up the same amount of space as 1 grain of sand. So clay particles are much tinier. The most important thing about texture is the way it can create the structure of the soil, and it can determine which plants will grow. You can't really change texture. It's just way too laborious if you have any kind of acreage to your farm or your landscape site to bring in a bunch of silt and mix it in. It's too much work. So what you do when you have a texture that's off is you usually amend it with just adding more organic matter, compost, healthy soil types like compost, and over time it will balance it out. Maybe not completely, but you can imagine if you've got an overabundance of clay, adding organic matter will break up the clay particles and make the soil more user-friendly for the plants. And it also adds some silt and sand to it. Even compost has that in it, so it will help kind of balance it out and not have the extremes of texture be so prevalent. So that's soil texture. We've also discussed soil structure. It's the way those particles, the mineral particles, are arranged into aggregates, like little clumps, granules, which are spheroidal, blocks, more blocky, cubical, and then there's also prismatic, there's columnar, there's different types of aggregates, and that's the soil structure. Why would we care about soil structure? Well, it is very closely related to pore space and pore size. The way those particles arrange themselves in a 3D structure will determine how much space there is between the particles, and that's the pore space, and that's where the air and the water is and the minerals that get dissolved into the water, where the roots grow, where the microbes get their oxygen, etc. And how well the soil drains, too, is determined by the structure. You can change the structure, so not so much texture, but structure, yes. Same kind of techniques though, adding organic matter, compost improves drainage by making the clay particles aggregate into smaller aggregates instead of larger ones, and the organic matter kind of wedges itself in between these smaller clay particles so they can't clump together. Some people use gypsum too for heavy clay, but adding organic compost and mulch is always going to help. Where are most of the soil microbes found? Usually in the top few inches of the topsoil. And why is that? Why are they located there? It's because that's where the most air is, the most water, the most organic matter, the most microbes. They all are, all that's happening in the top of the topsoil. There's a lot of microbes that are found in the topsoil. About 4 billion per gram in the first 3 inches in a typical soil, as opposed to 37,000 bacteria per gram or microbes per gram in 3 feet down. So a lot less once you get down to 2 or 3 feet deep in the soil. So most of them are near the surface, because the surface again is where the water is, where the organic matter is, where the roots are, where the nutrients are, and where the oxygen is, all of that. And the soil organisms are breaking down the organic matter and turning it into elemental nutrients which dissolve in the water, which can be absorbed by the plant. So those organisms are the ones making the nutrients available to plants. Also in that top few inches where most of the plant's feeder roots are the roots that are more shallow and absorb water and nutrients. Those roots also exude sugars, so they squeeze out sugars from the tips of the roots, which attract the bacteria to the root, and those bacteria also do decomposition of organic matter near that root tip. So the plant root tips are, again, feeding and building up, attracting the microbes to them, and the microbes then make the nutrients available to them. So there's a little bit of a reciprocity there. Okay, so now we've gone over reviewed some of the things related to basic definitions and characteristics of soil. Let's talk about composting now, a natural process of decomposition, but humans utilize that the ability of microbes to do decomposition and put it into a more artificial human-induced situation where we can hasten that whole process and make it happen quicker. That's composting. Healthy soils are a natural part of the process, the carbon cycle, the cyclical process of things growing and dying and decomposing and going back into the soil, then getting absorbed back by plants again and maybe eaten by an animal, etc. It's a natural cycle. And the part here, like imagine a leaf falling off of a tree, it lands in the soil, and then microbes decompose that, or fungi too, and a few other soil organisms, mostly fungi and bacteria. They will decompose that leaf. They will also decompose the dead gopher or animal matter. So it's microbes are making the nutrients that were in that organism available to the next organism by breaking that organism down through decomposition and releasing those elemental nutrients and elements into the soil from which they can be utilized again by plants. The biological action of some organisms in the soil create humus, which is a thick, rich organic matter. There's a whole bunch of different molecules making up humus, but it's that dark, thick, kind of almost gooey part of really healthy compost. Also, polysaccharides coat those particles, and they also coat the bodies of bacteria and fungi. Those polysaccharides are really important for soil structure that kind of help hold up the soil in its structure. Without the organisms, the soil kind of collapses in on itself. So pore structure, water drainage, and oxygen infiltration of the soil all depend on a healthy, living soil food web. Keep talking about humus. What is it? It's not hummus. That's a little bit different. That's something us humans would eat. But what is it? It's broken down composted remains of leaves, grass, and other organic matter. It's rich in minerals, and microbes are vital for the healthy growth of plants. So you need the microbes to create the humus, which is rich in minerals. And humus is able to hold about 80 to 90% of its own weight in moisture. So when you have thick, rich, dark humus in your soil, it's like a sponge, and that's really healthy for the soil, for the microbes, for the plants, etc. The functions of humus is to increase the soil's cation exchange capacity, the CEC. It's able to store more nutrients when you have more humus in it. And humus structure acts as a buffer against soils that may be too acidic or alkaline, so it helps buffer those soils and makes them more moderate for plants to grow in. And forest soils are naturally rich in humus from all of the falling leaves and undergrowth falling down and decomposing. Arid areas usually have very low humus content. Again, humus typically is very dark and organic matter rich. When we're doing composting at home, we're creating a situation where we can grow bacteria quickly and give them just what they want to make humus quickly too, to make a really rich humus-filled compost. We've kind of already answered this question, but what is compost? It's organic material that over time has been consumed by animals of all sizes, including microbes, but also mammals, birds, rodents, worms, microbes in the soil, fungi, insects, protozoa. And it's the natural life cycle of that compost. The bacteria decompose and digest that, and what's left over becomes part of the soil, or we can use it in our garden. Besides making a really good, nice compost to put in your garden or farm, There's also some other reasons to do it, a little bit larger scale environmental reasons, like returning nutrients to the soil that were in the plant. The plant got its nutrients from the soil. When they go up into the biomass of the plant, they're not in the soil anymore. But if you compost those materials back and put them on the soil again, then your soil will not become depleted over time in nutrients. It's good fertilizer for the tree, and it's free, or for other plants too. Reduces the amount of trash that you send to the landfill, so green waste volume goes down, which uses fossil fuels to transport that around and get it turned into mulch again and bringing it back. So we're reducing our carbon footprint. There are also lots of things in the green waste that can be have some toxicity to it, and decomposition and composting will break down those organic matters and some of those toxins too. In a landfill, composting doesn't really occur because it is an anaerobic situation. So trash is brought in, and they say, well, here in the Santa Barbara area, it's about 50 to 60% or more of what fills our local landfill is green waste. So it's definitely gotten better since we had green bins, but still people throw away a lot of stuff, especially kitchen scraps, like plant scraps from the kitchen go into the landfill. But they go into a situation in a landfill where there's a clay liner, so it's sealed from the bottom, and then they put a soil cap on top when they're done with that landfill, and that becomes anaerobic. So there's no oxygen in there, and anaerobic bacteria proliferate inside the landfill, creating methane, and but it does not create, it's not a composting process where you can now take that and use it for planting in a garden again. It's gone anaerobic. It's producing methane, which can be used, but all that trash is not available for use in a garden. So it's not a composting process. Why not? Let's go on. As I said, there's no oxygen in a landfill, so it really takes that green waste and the other waste and mummifies it. It's mixed, that food compost is mixed with non-organic plastics and other things in a landfill. If you've ever been to the dump, it is, there are some organic matter, there's wood, there's some plants, there's a lot of palm fronds, there's some green waste, but there's a lot of glass and metal and plastic and textiles. And so a landfill is built to encapsulate waste, not to break it down, but just encapsulate it. So it can take a lot of time for these things to ever break down, if ever. And so that's unfortunate. But the more we can separate out our green waste and our kitchen waste from our trash, the less trash will go into the landfill, and the more of those nutrients that are in our green waste and kitchen waste can be composted and utilized back in our soil again. Okay, let's talk about just your basic compost pile. So we're talking about a thermophilic composting system. That's the type most people use in their yard or garden. The minimum size has to be 3 cubic feet, and that's so it has enough interior space. The interior space is buffered from the exterior atmospheric temperature outside. There's enough kind of a seal thickness of the compost pile on the outside that it can get hot inside. It's insulated inside there. Like a high volume to surface ratio. You want a lot of volume with a lower surface area. You have a really small pile, you have a high surface area to volume ratio, and that just means that it would get, it's not insulated enough inside to get hot. Think of like, I always think of this like an adult human and a baby. Like if you take a baby out into cold weather, the interior of that baby will get cold really quick because it's not very far from the cold air into the very center of the, a little kid. But an adult is bigger, thicker, it takes longer. Compost pile is the same way. If you had a really small compost pile, the whole thing would stay cold and it wouldn't heat up. The bacteria that like to chomp on that green and brown stuff, your organic waste inside the composting pile when you first make it, they like the heat. They create their own heat, but that heat needs to be insulated, so that heat kind of builds on itself, and more bacteria grow and it gets warmer and it just really takes off. And that's when the decomposition process really also takes off. basic components of a compost pile. You have brown material, that's plant material that is dried, brown-ish. Green material, and that is green plant material. It's fresh. That's the nitrogen source. There's a lot of nitrogen in green, fresh material. And the brown material is a carbon source. So when you take, say, like grass clippings, when they're green, they just cut them, they have a lot of nitrogen in them. But if they sit around and they dry out, most of that nitrogen volatilizes it. It off-gases. It enters the atmosphere from inside those cuttings, those grass blades, and it helps it, it dries up and it turns brown, and then it doesn't have much nitrogen left inside of it anymore, and has a lot of carbon though. So dried grass clippings would be great for brown material. Green, fresh grass clippings would be great for the green material and the nitrogen source. You also need water and air and time and some kind of inoculant. That can just be soil from around the place you're gardening, like native soil. You can also use finished compost that you already have. Some people will also add a composting starter. You can buy it. It's got nutrients and sugars to feed the microbes. It's not necessary at all, but you do have to put some kind of soil, and that you're just putting microbes, inoculating that pile with more microbes. Those are the 6 main ingredients, usually 5, not including time. As far as carbon-nitrogen ratios, usually you want about 2 to 3 parts of brown material to 1 part of green material. And that will get you a good ratio of about 25 to 1 carbon to nitrogen. Here are a number of different things you could add into your compost pile and their carbon-nitrogen ratios. So let's just look at like the big numbers, like sawdust, 200 to 1, so almost all carbon, hardly any nitrogen. But then you have something like fresh manure, 8 to 1. So there's a fair amount of nitrogen in that. There is carbon, but it's balanced out by a fair amount, an eighth the amount of carbon is in nitrogen. So that would be a pretty high nitrogen source. Sewage sludge is similar, and then you have the other numbers there too. So you don't really have to calculate all these numbers to make sure it's 25 to 1. When you do the 2 to 3 parts of brown to 1 part of green, you get about a 25 to 1 ratio. Here are some examples of brown material that are carbon rich. Usually have some of these around. And here's an example of some green nitrogen rich materials that you can add to your compost pile. Kitchen scraps are good. The only thing about some of these first ones, like kitchen scraps, ground eggshells, coffee grounds, is that you can add them to the compost pile. They're great, along with manure, feathers, leaves. But once you build your compost pile, you can't keep adding things to it. So you build it to create a system to make the bacteria start to proliferate and grow and start the decomposition process. And once it starts going, if you started adding some new stuff, it would throw it off. So the only reason I say this is because kitchen scraps is something you get, you have them every day. But once you start your so it's only like a couple of days gathering of kitchen scraps could be thrown into a compost pile. But then you start the pile and you don't add anything more to it till the compost is done. So all your other kitchen scraps would be better utilized in like a worm bin, which you can add kitchen scraps to them every single day, and they get broken down into nice worm castings. So a lot of you have probably already done some composting, and you probably have heard, don't put meat, don't put dairy. Those things aren't so good for a compost pile. You may have also, probably guessed not to put pet waste or kitty litter, that kinds of stuff. Those are obvious. Pet waste, kitty litter, they have a lot of pathogens in them that aren't good for people. But the meat and dairy is not really it's not really a no-no. You can put that in a compost pile. It's just that usually it has to be a pretty big compost pile to be able to handle higher fatty foods for decomposition. So if you're doing a smaller compost bin or pile, you do want to exclude the higher fat products like dairy products and cheese and meat. But it's not because those don't decompose. It's because, one, meat and dairy attract rodents, like things like, raccoons or skunks or possums or rats, and people don't want to attract those to their house, but also that their pile just isn't big enough. You need a pretty big pile to handle the fats. But I've seen compost piles that aren't, much more than 6 by 6 by 6, and whole animals can be thrown in there and they'll decompose after a while, including bones and things. So, but for home style, stick with the 3 to 4 cubic feet, and those are good. Besides keeping to the, let's say, just 2 to 1 brown to green material ratio, another way you can try to keep the ratios correct from nitrogen and carbon are to do about a foot layer on the bottom. So you start to build your pile. It's 3 foot by 3 foot. Put in a foot of brown material on the bottom, then put 6 inches of green on top of that. Sprinkle in a little bit of compost or garden soil. Soak it with water till it just starts to run out the bottom and stop, and then repeat until it gets to about 3 feet tall. And then you cap it with a little soil or some, if you got some nice organic mulch, and there's your compost pile started. There are many different types of composting methods. On the left in this image is showing a biodynamic pile, where you're using soil and green material and then brown material, which says dry, and then some kind of stalks, leafy sticks for aeration. And you would keep that, repeating those 4 layers over and over until you get your minimum size. And on the right pile, the indoor method, indoor is a name, not thinking about inside. That's using soil, manure, and dry material. That's another type or recipe for composting. Again, many types are possible. The Rodale Book of Composting is a great one that outlines all different kinds of piles and ingredients and what works best in different kind of situations, including environments. So the temperature and the climate is going to affect your composting process. So there are certain things to do when you're in like a really hot tropical humid climate, or cool temperate climate would have other types of methods. So you set up your pile, like we just was talking about, and then you leave it there. The pile should heat up. It should heat up to about 120 in the first few days. If it never gets to 130 in the first week, then you're going to have to remake it and add more nitrogen. So the fresh green material that has all the nitrogen, that's what heats it up. The bacteria, so back up for a second, there's lots of different species of bacteria that live in a compost pile, that live on plant leaves and stems. They're always on there, just like our skin. They're all over the place. When you build a compost pile, you're putting all the food and the bacteria are in there already. There's some on the leaves, there's some on the grass clippings, there's some on the green waste, there's some on the sticks and things that you put in there, brown material and green material. But the first ones to really love that situation, those thermophilic or heat-loving bacteria, like it when you build a pile. They're the first ones to be like, yay, we're in this perfect situation. We've got everything we need to eat, and they go cuckoo. And those are the ones that heat up the pile, the ones decomposing the green material. So if it doesn't get hot enough, you didn't put enough green in, and this will happen. It's going to happen. It's not like you had a big failure. You just have to remake it pretty quickly and add more green material. If the pile gets over 150 degrees in the first few days, then you've made it too hot. It's going to be too hot, and it will not, it'll hinder the decomposition process because it's too hot for that biochemical reaction to occur in those microbes. They'll get slowed down by that. So you'll have to turn it again. You don't have to remake it, but you have to turn it, aerate it, cool it down by breaking it up and turning it from one spot to the next. Like this man who's building a compost pile. I like when we use the cages. I like to use cages instead of the plastic kind of containers, because these cages often are just a cylinder of like chicken wire or hardware cloth, and you can build it and fill it up like he's doing, and then when you need to turn it, you could just open up the part of that cylinder where the two parts of the wire join, just open it up and lift it off and move it to another place nearby, and then take that pile that it was surrounded by the wire, and now it's freed from that. You can just move it, just turn it into the new cylinder of wire that you've moved over a couple feet away. So it's a real simple process. You can add organic fertilizer, as I said in an earlier slide, for a nitrogen source to heat it up, or you can add manure or a leguminous plant material, so a plant that is a nitrogen fixing plant. There's lots of different leguminous trees and plants and some shrub leaves that are high nitrogen. Manure is one of them. It is a high nitrogen material, but a leguminous plant would be, we have things like mimosa tree, ice cream bean tree, tipu, cassias, anything in that pea bean family is going to be great to add even more nitrogen and get it heated up if it did not on its own. How do you know when it's done? That compost, after a few months, it shouldn't be no longer hot or steaming. The pieces are small. You can't recognize big chunks of sticks or leaves. And it smells good, like forest soil. Something that most people think smells kind of good. It shouldn't smell bad, and it shouldn't be hot, and it shouldn't be, still like huge chunks all over the place, like no decomposition happened. You will get some chunks of sticks and things, and usually what I do is I'll sift it out. I'll sift it through some kind of mesh wire so small pieces fall through. The smaller stuff, which is just pretty much like good soil, use that in the garden, then take all those things that didn't decompose all the way and put them back into the next pile. You need to turn the pile a few times to incorporate oxygen during those first couple of weeks, and then you pretty much just let it sit there. What's happening in the compost pile, like I said, you've got one group of bacteria that are growing right away. They're eating the green material, and then the process slows down a little bit, and then you get more, the brown material starts to be decomposed by fungi, and that can last quite a while. But that's the process. You have a certain group of microorganisms that do really well at the beginning, and they heat up, and then the pile, another group of organisms, soil organisms, kind of take over, and it's kind of the bacteria to begin with, and then the fungi after the first month kind of take over for the rest of the time of the compost pile. The fungi are doing most of the decomposition. Are we achieving balance with our compost? Is our texture good? Is the organic matter levels good in our soil? How do you know? If you're composting, one good thing you can know, as I mentioned earlier, is adding compost is going to help balance the soil naturally by adding a lot of good composting. You want to have about 5 to 6% organic matter in your soil overall. For sandy soils, that's more about 3%, loam soils about 4 to 5, and clay soils about 6 to 7% organic matter is what's going to make that soil healthy. With clay, you need more than with sand. And there are tests you can do to determine the organic matter in your soil. The texture test does not measure organic matter, it just measures the sand, silt, and clay. But you can test it for that and figure out if your soil has the right levels of organic matter. There are lots of different kinds of compost bins that you can use. The chicken wire cylinder, pallets, put into 4 sides. You could do a plastic trash can with holes in it. There's this wine barrel, which is a fancy one, that spins on little wheels, snow fencing, etc. You can just use an open air pile too. There are lots of different compost bin sizes and shapes. These are all enclosed bins, different ones that look maybe attractive, like the upper left, or ones the lower left where it spins on its own little rod axis. The lower right is actually a type 2. It almost looks like a worm bin, but it's actually a different type of composting bin. These are all okay. They're a little hard to turn if you need to turn them. Like the spherical one looks kind of neat, but it's really kind of awkward getting in there and mixing things around, I find. A few more types. The upper right one is the one that's sold by the county. If you go to the dump, you can get them. Other places too. They work okay. And again, though, you have to, if you have to turn your pile, you have to lift that whole thing up and off of all your filled up material to another site and then turn the material back into it. Yeah, they're okay, but they're good in the sense of like animals can't get into it. You can kind of lock the top cover. I like, of all these types, the bottom right one, just a four-sided cage, really simple, where you can throw things in. You can see what's in there. There's a lot of good aeration, and when you need to turn it, it's really simple just to pull that off. Often one little side unlatches, and just set it 1 foot away, and then turn it into the new location. Other forms of composting, of course, you've heard of worm composting. That's vermicomposting, which is great for a home with maybe you don't have a lot of land to do composting outside and you want to compost all your kitchen scraps and you can throw stuff in there every day. One worm bin, the size of kind of like a big Rubbermaid bin, a storage bin, could have enough worms in it to handle a family of four's kitchen waste. So that's a really nice size. There's other ones called Bokashi. There's Windrow composting, big, long, outdoor open piles that can handle stuff being added to them every day. Sheet composting, more like sheet mulching. There's pet waste composters and indoor, really attractive, high-end composting systems as well. A simple system for worm composting inside. Take that Rubbermaid bin and drill holes in the bottom and on the sides to give aeration and drainage. Take some shredded paper or cardboard for bedding. You can put kitchen scraps in there. You've got to buy worms to start it and just keep it moist, but don't have the lid of the bin on it too so they don't get flooded out by rain. But there's a lot more to it, but there's not that much more to it to get started, but you can learn a lot more as you do it. But these are really nice systems, and you get great worm castings out of it that are just super rich in nutrients for your plants in the soil. This is the Bokashi composting system, which is more labor intensive. It's a little more technical than just building a pile with brown and green. You've got to buy the usually people buy the kit and they buy the starter and you add the bacteria to it that do this particular composting process that can be done like in a 5-gallon bucket under your sink. It's it's an expensive type of situation, but it's great for small spaces and it's odor free. But it is produces a really good product too, but you have to stop and take this out and harvest the decomposed organic matter at a certain point. It's using an anaerobic process as opposed to aerobic, which we talked about first with all the piles. These are large windrow composting piles, and kind of on a commercial scale. This would happen to all of our green waste that we get from we put in our green waste containers here around the Santa Barbara area. All of our green waste gets trucked to Santa Maria, about an hour north of here, and put in these big piles where it's partially decomposed for a couple of days, and then it becomes our mulch that you can buy back from the county. There's also a method called lasagna gardening or sheet composting, where you put layers of different things, carbon-rich nutrients, onto the soil. Layers of maybe paper and brown material with green waste. And in a way, you do it outside in a place where you're trying to build a garden bed. So you're doing composting in this long, thinner, lasagna-like method right in the spot where you're going to plant into later. There are dog waste composters too. Some people like to just dig holes in the ground and bury their pet's waste, or they throw it in the garbage. But if you're going to compost it, there are things to find out about how to do it. This is one particular system. It's a commercial system that you're looking at. So if you're interested in that, I encourage you to look into more of the details about that. And fancy indoor composters that can be put underneath the sink or in a cabinet. They don't really work as well as they're making it look like, where you put in the green scraps at the top and then out comes this nice pot filled with compost a little later, 2 weeks they say. It's a little messier, you've got to fiddle with it, and the compost isn't perfect, but there are ways to get some of the composting done on a cleaner, more tidy scale. And once you do get your finished compost, there's lots of great things you can do with it. You can start seeds in it. You can add it to commercial potting mix, or you can add it to the soil. If you're planting new plants that you bought from a nursery, it's great to dig that hole about twice as big as the pot that you get the plant in. And in that extra space that's not taken up by the root zone from the plant that you buy, mix your native soil with the compost in that outer area, and the roots will grow out into it, and it will set that plant up to have a healthy, strong root system. You can also use your compost as a mulch around the plants that are important to you or that need it. It's good for your lawn. Lots of uses.